to see if it works or not. So if it can detect lightning, it will turn red. If it won't turn, if it doesn't have lightning, it will turn green. Or if it has interference with sound that cannot be detected and transmitted to the lightning, then it will turn yellow, just like that. So let's start simulating.
Sure.
So first we're gonna put it near our computer. I'm just gonna power off my computer just in case if it works or not, because I tried it earlier and it works, so I don't know if it's just by coincidence or...
Now look at there's like red, green, and yellow. See if it works. The red was
No, let me first
like
shut it down and restart my computer.
So yeah. While we wait, also when it detects a lightning, it will say 191 on here.
Yes, exactly. So
if it doesn't detect, it'll keep saying the same thing, 190.
So for example, that it must turn 191 because it detected lightning. So yeah, it's 191 and our mission 66 has been a success.
Now it's 191.
Yes. So let's go to MQTT broker, see if it actually shows or not.
As you can see, I don't see any message. Now there is a message.
Yes.
And it says 192. And this side, it also says 192.
So this means that we prove these two works good. So let's start with analyzing the community lightning alert system architecture. So first, let's start with the lightning system, what I'm holding right now. It will send a signal to the RTL SDR USB receiver, which is right here, as you can see here. And then this USB receiver
is going to send to the
here.
edge decoder, which is like a code.
And then it's going to send to the cloud MQTT broker, which is in my computer. And then it's going to send to the IOSS app. The problem is we used instead a simulator that resembles to a